In the name of Allah, who is merciful and beneficent. My name is Hazina Tahir, and my today's topic is GCMS, gas chromatography and mass spectrometry. My roll number is 30, and my group number is 4, and my part was first. Gas chromatography is a term used to describe the group of analytical separation techniques used to analyze volatile substances in the gas phase. In gas chromatography, the components of a sample are dissolved in a solvent and vaporized in order to separate the analytes by distributing the sample between two phases, stationary phase and mobile phase. Mobile phase. Uh, we also call mobile phase a carrier gas, is a chemically inert gas that serves to carry the molecules of the analyte through the heated column. Gas chromatography is one of the sole form of chromatography that does not utilize the mobile phase for interacting with the analytes. Mobile phase is comprised of inert gas like helium, argon, and nitrogen. The stationary phase is either a solid absorbent termed gas solid chromatography or a liquid on a net spot termed gas liquid chromatography. Stationary phase consists of a packed column in which the making or solid spot itself act as a stationary phase or coated with a liquid stationary phase. So हम high boiling polymer भी कहते हैं. There is an introduction of gas chromatography. In early 1900s, gas chromatography was discovered by Mikhail Samanovich Savat. It is a separation technique to separate compounds. In an organic compound, liquid solid column chromatography is often used to separate organic compounds in a solution. Among the various types of gas chromatography, gas liquid chromatography is the method most commonly used to separate organic compounds. The combination of gas chromatography and mass spectrometry is an invaluable tool in the identification of molecules. Typical gas chromatograph consists of injection pod, a column, carrier gas flow control equipment, ovens, and heaters for maintaining temperatures of the injection pod and column, an integrated chart recorder, and a detector. We study about the stationary phase. Stationary phase is a microscopic layer of liquid or polymer or an inert solid spot inside a piece of glass or metal tubing कल जिसको हम column कह रहे हैं. To separate the compound in gas liquid chromatography, solution sample that contains organic compounds of interest is injected into the sample pot where it will vaporize. The vaporized sample that are injected are then carried by inert gas, which is often used by helium or nitrogen. The inert gas goes to a glass column packed with a silica that is coated with a liquid. Materials that are less soluble in liquid will increase the results faster than the materials with greater solubility. The purpose of this model is to provide a better understanding on its separation and measurement techniques and application. In glass liquid chromatography, the liquid stationary phase is absorbed onto solid inert packing or immobilized on capillary tubing walls. The column is considered packed if the glass or metal column tubing is packed with small spherical inert spots. The liquid phase absorbed onto the surface of these beads in a thin layer. In a capillary column, the tubing walls are coated with stationary phase or absorbing layer which is capable of spotting the liquid phase. Here the instrumentations of gas chromatography. First is sample injection. A sample pot is necessary for introducing the sample at the head of the column. Modern injection techniques often employ the use of heated sample pods through which the sample can be injected and vaporized in simultaneous fashion. Calibrated microsyringes used to deliver sample volume in the range of few microliters through a rubber septum into vaporized chamber. Most separation requires a small fraction of initial sample volume and sample splitter used to direct excess sample to waste. Commercial gas chromatograph often allow for both split and splitless injections when alternating between packed column and capillary column. The vaporization chamber is typically heated 50 degrees above the lowest boiling point of the sample and subsequently mixed with the carrier gas to pour the sample into the column. Here the picture of injection. Sample injection, the syringe, septum purge, carrier gas vaporization chamber, syringe needle, septum. and column. Carrier gas is an expat. The carrier gas play an important role in various in GC used. Carrier gas must be dry, free of oxygen, chemically inert mobile phase employed in gas chromatography. Helium is most commonly used because it is safer than others. Comparable to hydrogen in efficiency, has a larger range of flow rates and incompatible with many detectors. Nitrogen, argon, and hydrogen used depending upon their desired performance and the detectors being used. Both hydrogen and helium, which are commonly used in most traditional detectors such as flame ionization (FID), thermal conductivity (TCD), and electron capture (ECD), provide a shorter analysis time and lower elution temperatures of the sample due to the higher flow rate and low molecular weight. For instance, hydrogen and helium as a carrier gas give the highest sensitivity with thermal conductivity because the difference in the thermal conductivity between the organic vapor and hydrogen and helium is greater than other carrier gas. Other detectors such as the mass spectroscopy uses nitrogen and argon, which has much better advantage than hydrogen helium due to their higher molecular weight, in which improve vacuum pump efficiency. All carrier gases are available in pressurized tanks and pressure regulators, gauges, and flow meters used to control the flow rate of the gas. Most gas supply should fall in between 99.95 to 99.995% purity range and contain a low level of oxygen and total hydrocarbon in the tank. The carrier gas system contains a molecular sieve to remove water and other impurities. Traps or other options to keep the system pure and optimum sensitive and removal traces of water and other contaminants. Two-stage pressure regulation is also required to use to minimize the pressure surges to monitor the flow range of gas. To monitor the flow range of gas, a flow or pressure regulator was also required onto both tank and chromatograph gas inlet. This applies different gas type which use different type of regulator. The carrier gas is preheated and filtered with a molecular sieve to remove impurities and water prior to being introduced to vaporization chamber. Carrier gas is typically required in gas chromatography system to flow through the injector and push the gaseous components of the sample onto GC column, which leads to detector. Column over was the third part of instrumentation. The thermostated oven serves to control the temperature of the column within a few tenths of a degree to conduct precise work. The oven can be operated into two manners: isothermal programming or temperature programming. In isothermal programming, the temperature of the column is held constant throughout the entire separation. The optimum column temperature for isothermal operation is about the middle of boiling range of the sample. However, isothermal programming works best only if the boiling range of the sample is narrow. If a low isothermal column temperature is used with a wide boiling point, the low boiling point frictions are well resolved, but the high boiling point frictions are slow to elute with extensive band broadening. If the temperature is increased closer to boiling point of the high boiling components, the high boiling component elute as a sharp peak, but the low boiling component elute as so quickly that there is no separation. In the temperature programming method, the column temperature is either increased continuously or in step as a separation progress. Method is well suited to separating a mixture with a broad boiling point range. The analysis begins at low temperature to resolve the low boiling components and increase during the separation to resolve the less volatile high boiling components of the sample. Rates of 5 to 7 degrees per minute are typical for temperature programming separation. Isothermal and temperature programmable operations. In isothermal operations, the column temperature is constantly maintained at decreased sample throughput throughout. Run times are longer than temperature ramping. Broad peaks for late eluting components. यहाँ पे जो है डिक्रीज सैंपल थ्रू आउट है, यहाँ पे जो ब्रॉड पीक्स है फॉर लेट एल्यूटिंग कंपोनेंट्स, कैरी ओवर इफेक्ट फ्रॉम हैवियर कंपोनेंट्स. The major disadvantages: temperature programming In temperature programming, the ramp rate and the temperature profile can be adjusted during the run. The illusion of desired components can be accelerated by optimizing the temperature profile of each model. There are the advantages of temperature programmable operation. A higher sample throughout, less carryover, extended application range on a single column, sharper peaks for late eluting components. In these diagrams, these graphs show the effect of column temperature on the shape of the peaks. Shape of peaks show the effect of column temperature. Low isothermal temperature, high isothermal temperature, and program temperature. Open tubular column. Open tubular column, also known as a capillary column, come into two forms. The first is wall-coated open tubular column, and the second is spot-coated open tubular column. Wall-coated open tubular column are capillary tubes that have a thin layer of stationary phase coated along the column walls. In second type, the spot-coated open tubular column, the column walls are first coated with thin layer of absorbent solid, such as diatomaceous earth, a material which consists of single cell sea plant skeleton. The absorbent solid is then treated with a liquid stationary phase. While spot-coated open tubular columns are capable of holding a greater volume of stationary phase than, than a VCOT column due to its greater sample capacity. Most modern VCOT columns are made of glass, but T316 stainless steel, aluminium, copper, and plastic have been used. Each material has its own relative merits depending upon the application. VCOT column have a distinct advantage of chemical etching, which is usually achieved by gaseous or concentrated hydrochloric acid treatment. The etching process gives the glass a rough surface and allow the bonded stationary phase to adhere more tightly to the column surface. One of the most popular types of capillary column is a special VCOT column, which called a fused silica wall coated FSWC open tubular column. The walls of fused silica column are drawn from purified silica containing minimal metal oxides. The columns are much thinner than glass column, with diameter as small as 0.1 millimeter and length as long as 100 meter. To protect the column, a polyamide coating is applied to the outside of the tubing and went into coils to fit inside the thermostated oven of the gas chromatography unit. Fused silica wall coated open tubular column are commercially available and currently replacing older column due to the increased chemical inertness, greater column efficiency, and smaller sapling size requirements. It is possible to achieve up to 40,000 theoretical plates with a 100-meter VCOT column. Yet the world record for the largest number of theoretical plates is over 2 million plates for 1.3 kilometer section of column. Packed column. Packed column are made of a glass or metal tubing which is densely packed with a solid spot like diatomaceous earth due to the deficiency of packing the tubing uniformly. These types of column have a large diameter than an open tubular column and have a limited range of length. Diatomaceous earth, diatomic, is a naturally occurring soft siliceous sedimentary rock that has been crumpled into the fine white to off-white powder. As a result, PAG column can achieve about 50% of efficiency of a comparable WCOT column. Furthermore, the diatomaceous earth packing is deactivated over time due to the semi-permanent absorption of impurities. In contrast, FSWC open tubular column are manufactured to be virtually free of these adsorption problems. Had a picture, computerized picture of S fused silica column. Polyamide coating fused silica stationary phase with ingenious self cross-linking technology. How do you use it? Different types of columns can be applied for different fields depending on the types of sample. Some gas chromatographic columns are better than others. For example, the FSWC column is designed specially for blood alcohol analysis. It produces fast run times with baseline resolutions of key components in under 3 minutes. Moreover, it display it it display enhanced resolution of ethanol and acetone peaks with help with determining the BAC level, blood alcohol consumption level. This particular common column is known as Zebron BAC and is made with polyamide coating on the outside, and the inner layer is made of fused silica, and the inner diameter range from 1 0.18 millimeter to 0.25 millimeter. There are also many other Zebron brand column designed for other purpose. Zebron BAC level is a column specially set designed for accurate blood alcohol analysis, enhanced resolution of ethanol and acetone peaks. First run time with baseline resolution of key components in just 2 minutes. Detection system. The detector is a device located at the end of the column which provides a quantitative measurement of the component of the mixture as they elute in combination with the carrier gas. In theory, any property of the gaseous mixture that is different from the carrier gas can be used as a detection method. And there are the two categories: bulk properties and specific properties. Bulk properties, which are known as the general properties, are properties that both carrier and allied process but to different degrees. Specific properties such as a detector that measure nitrogen phosphorus content have a limited application but compensate for this by increased sensitivity. Each detector has two parts that were used together. They serve as a transducer to convert a detected property change into electrical signal that is recorded as a chromatogram. The first part of the detector is a sensor which is placed as close column exit as possible in order to optimize detection. The second is the electronic equipment used to digitalize the analog signal so that the computer may analyze the acquired chromatogram. The sooner the analog signal is converted to the digital signal, the greater the signal to noise ratio become as an analog signal are easily susceptible to many types of interferences. Chromatogram is a visible record, such as a graph, showing the result of separating the components of the mixture by chromatography. Here, the typical gas chromatographic detectors, types, applicable samples, and their limits. Flame ionizations के applicable sample are hydrocarbons, and their limit is 1 pgs. Mass spectrometer, tunable for any species, 0.25 to 100 pg. And furthermore, GC analysis. A gas chromatograph is a chemical analysis instrument for separating chemicals into complex samples. A gas chromatograph uses a flow through a narrow tube known as a column through which different chemical constituents of sample pass into the stream, mobile or carrier phase, at different rate depending upon their various chemical and physical properties, and their interaction with a specific column fill and tertiary phase. Chemical exit the end of column. They are detected and identified electronically. Function of stationary phase in the column is to separate different components, causing each one to exit the column at different time. Retention time. Other parameters can be used to alter the order or time of retention as a carrier, gas flow rate, column length, and the temperature. In GC analysis, a known volume of a gaseous or liquid analyte is injected into interest head of the column, usually using a microsyringe, a solid phase micro extraction fibers, or gas source switching system. As the carriers gas sweep the analyte molecules through the column, this motion is inhibited by the adsorption of the analyte molecules either into the column walls or onto packing materials in the column. The rate at which molecules progress along the column depend on the strength of adsorption, which is turn depend on the type of molecule and on stationary phase material. Since each type of molecule has a different rate of progression, the various components of an allied mixture are separated as they progress along the column and the reach of the column at different times. A detector is used to monitor the outlet stream from the column. The time at which each component reaches the outlet and amount of that component can be determined. Here the picture. Sample, gas chromatography, mass analyzer, electron ionization, column and sample injector. Methods. The methods is the collection of conditions in which GC operate for a given analysis. Method developed is the process of determining what conditions are adequate for ideal for the analysis required. Conditions which can be varied to accommodate a required analysis include inlet temperature, detector temperature, column temperature and temperature program, carrier gas and carrier gas flow rate, column stationary phase, diameter and length, inlet type and flow rate, sample size and injection technique. Carrier gas selection and flow rate. Typical carrier gas include helium, nitrogen, argon, hydrogen, and air, which gas to use is usually determined by the detector being used. For example, a DDI requires helium as a carrier gas. DDI, direct inward dialing. When analyzed gas samples, however, the carrier is sometimes selected based on the sample matrix. For example, when analyzing a mixture in argon, argon carrier is preferred because the argon is simple does not show up the chromatography. Safety and availability can influence carrier selection. Stationary compound selection. The polarity of the solute is crucial for the choice of stationary compound, which is the optimal case would have a similar polarity as a solute. Common stationary phase in open tubular columns are cyanopropyl phenyl dimethyl polysiloxane, carbovex polyethyl glycol, cyanopropyl phenyl polysiloxane, and diphenyl dimethyl polysiloxane. For packed columns, there are more options are available. Inlet taps and flow rate. The choice of inlet tap and injection technique depend on sample is in liquid, gas, or absorbed solid form. On whether solvent matrix is present and then can be vaporized. Dissolved sample can be introduced directly onto the column via COC injector if the conditions are well known. Sample size and injection technique. Sample size, a real chromatographic analysis starts with an introduction of sample onto the column. The development of capillary gas chromatography resulted in the many practical problems with the injection technique. The technique of on-column injection, often used with packed column, is usually not possible with capillary columns. Here the tube of injection, portion of sample containing analyte, end of a column, volume occupied by analyte, column selection. The choice of column depends on the sample and the active measure. The main chemical attribute required when choosing a column is the polarity of the mixture, but functional group can play a large part in column selection. Polarity of the sample must closely match the polarity of the column stationary phase to increase resolution and separation while reducing runtime. Column temperature and temperature program. The column in GCR contain in oven temperature, which is precisely controlled electronically. The rate at which sample passes through the column is directly proportional to the temperature of the column. The higher the temperature, the faster the sample move. The faster sample move through a column, the less it interacts with stationary phase and less analyte is separate. A method which hold the column at the same temperature for the entire analysis is isothermal. Most method, however, increase the column temperature during analysis, and the initial temperature rate of temperature increases, and final temperature occur temperature program. Thank you. There is my part, and the next was continue by the rest of class, rest of my parts.